Let's see. You have 2 or 3 students together.
Can I change it now?
That's good. Yes, you can discuss with each other. Then well.
I need Scott.
Professor,
We could.
Really? Okay. I think you'll be fine. He's nice. I know him. So now, well, that's what I do in the class.
You guys can't sit together.
Yeah, because
Yeah,
you get
that's
2
right.
or 3 students to sit together, the group, and when I give you an example, you have classwork and you discuss with each other. And when you do it, like I can help you too. I walk around the classroom and teach you, and it's going to be an active class. I want you to discuss and ask me questions, and not like I'm doing myself. You have to do it as a group. I help each other. Okay. All right. I'm assuming the other side has not been ready for it.
She's not there yet.
Yeah. We
And
can.
I'd say go ahead. 'cause
Just
you're-
go. I'm taping it
you're
anyway.
taping it.
Just
Oh, okay.
She'll have a
So
chance
we.
to see.
Okay.
she may be.
Yeah, before the class and what's her name again?
Gary.
I talked to him and he said, well, there's other candidates, 3 candidates here, and they talk the same thing, explanation. He said, really? Okay, I'll give you the same topic again. I said, I'm going to give you a short, simple topic because they have to listen this for 3 times. This is the 4th time. It's going to be boring for them. So today we're going to. Again, I mean, I think you have now listened to this topic. It's going to be an introduction to exponential function with its application, a little bit application. Okay, first I will give an introduction why we need to learn the exponential function. Otherwise, you're wasting your time of sitting here. You want to learn something that you will use, possibly use in the future. After you walk out of the classroom, that's really important. We learn math. Is that why we have to use it, not pass in the class and get a degree and then nothing with the math. Actually, all the math knowledge, any math you can use in the future. Okay, there's a legend or story about the exponential function, which you may have heard from the previous candidate. Okay.
Pretend you know nothing.
Okay, pretend you know nothing. Yes. Okay, so now, well, in the classroom, the same thing happens. Some students may hear this story before. Now, there's a wise man, and he helped the king to win a battle. Then, because in the ancient time, they like to play chess with each other. Now we still play. And then the king asked him, "Well, what do you want as a reward, like because it helped me to win the battle?" And he said, the wise man, he's very smart, and he says, "Well, I don't want anything. I'm not interested with the gold and anything else. I'm interested with rice like here." So I want you to give me some rice. The king said, "Okay, how much rice do you want?" He says, "Now we're playing chess because you know." Kings play with the wise men, they always play chess with each other and want to learn practice. Oh, okay. He said, "Now I want you to give me 1 grain of rice in the first square of the chessboard. And the next one, you give me 2. The next one, you give me 4. The next one, you give me 8. Like you always put the amount double the previous one. So the chessboard has 64 squares. Well, the king said, oh, he's not good with math. He thought, okay, he thinks, oh, that's not a big deal. You see, 1 pound of rice is about 26,000 grains of rice. I can fill this board with maybe 10 pounds of rice. Well, 100 pounds of rice will be enough to just put it here and the whole chessboard will be full, covered with the rice, right? He thinks, oh, that's easy. Okay, I'm going to... so he agrees. Say, okay, I can satisfy your requirement. Then what do you think next? Okay, after a few hours later, the treasurer of the country, because they said yes, we can do that. Then they ask someone to say, okay, give him that rice, put it on the chessboard, and then they amount it. Then what happened next? The first one is 1, next one is 2, next one is 4, because I always double the previous amount, right, for the next one. And it's 8, 16, 32, 64, 128. All of this is kind of okay, but after you go to the last one, or the treasure came back to kingdom, oh, master or lord, we don't have any rights anymore. We cannot pay him off in the next few years because that's too much than we can afford. Now you can see, say just 29,000 of grains of rice in 1 pound, and it's going to be about trillions of pounds of rice. Well, they can never pay it off. Well, that's very interesting because that's the power of exponential function. Okay, because it's exponentially increasing. If the king, he knows that property of the increasing so dramatically, he will not agree to give him that reward. So it's a funny story. Anyway, we know it's the exponential function. It has a property of dramatically increasing, exponential increase, or exponential decrease. Okay. Well, that's a story. But now maybe you say, why don't you use that now? But how about now? Is it why do we need to learn it? I don't play chess. I don't do that. Just you use it? Well, the answer is yes. And here you can see an example. Suppose you make a deposit, $2,000 into the bank. You want to figure out, the bank will tell you it's going to be paid, it's going to be, the interest is 6% or 5%, what percent, 6% compounded continuously or quarterly. They're going to tell you the compound interest, what's the rate, how are they going to compound the interest. And then you want to find out the amount in account after 3 years, or you can figure out how much the interest will be. Because you figure out yourself, and then you can have some other investment. You can compare, is it better to put it in the bank or put it in other investment? Does that make sense? So that's why after this class, you can figure this out. You can tell, oh, I put $20,000 in the bank, and after 3 years in this interest or different interest, I can figure out how much the interest will be. So it's very important, very realistic. When you finance a house, and how much they tell you the interest you need to pay back, they give you the rate. You can figure yourself how much a month I need to pay back to the bank. So it's very realistic, very important. Okay, that's why we need to learn the exponential function. So next question is, what is an exponential function? Given the following table x and y values, you can look at here is x is 1, 2, 3, 4, 5, 6 until any number n or x. The y value is 1 is 2. The next one is 2. This is 4, 3 and 8. Next is 4, 16, 5 and 32, 6, 64. Which of the y value is always this one is, you can figure out what's the pattern between x and y. Can anyone tell me the relationship between x and y? Which right here, we can tell that, okay? If supposed to here. So you can look at the y values is the 2 to the x power. So this is 2 to first power, 2 square, 2 cube, 16 2 to the power 4th, 32 is 2 to the power 5, 64 is 2 to the power 6. So basically have a relationship between x and y, and then we have a function which is y equals 2 to the power x. And previously we always have function like y equals x plus 1, or x squared, which is x squared plus 2x, which is quadratic function. You have y equals x plus 1 linear equation. But now, where is the x? Where is the x? Where is the x? It's the power, which is the exponent. Good. So it's the exponent. That's why we call this function exponential function, because x is in the exponent position. Okay. All right. So now, any function has the form fx equals 8 to the power x. 8 can be any number bigger than 0, 8 not equal 1. It can be 2, 3, 5, 4, any number as long as it's positive and not equal 1. Now I have a question for you. Why is A positive?
Because for anything to grow, you have to have something.
Anything to grow, you have to have something? Well, the question is A is positive. Say, I'm going to say, what if I have the definition? Okay, we refer definition here is fx equals 8 to the power x. It's going to be exponential function. A has bigger than 0, A not equal 1. That's the requirement. If I have anything negative, say example, What if I have x equals negative 2x? What happened?
Going from positive to negative, positive to negative.
Yeah, positive, negative. That's a very good answer. Okay, you can go positive, negative oscillation. That's actually okay, you go positive, negative, but the point is, if this is negative, say if I give you something like this, negative 2 to power 1/2. What is negative 2 to power 1/2? It's going to be 1/2 power. In the previous class, intermediate algebra, we know half power, 1/2 power is going to be square root. So it's going to square root of negative 2. What happened with the square root of a negative number? It's not a real number. Okay, so we have learned this in the previous class. If the square root of a negative number is not a real number. So our function here we define is under the real domain. So if it's imaginary, it's not an imaginary function, so we don't have a real number here. So that's why we cannot have the exponent, the base is on the base and this exponent. We cannot have the a negative. This is the first question. Second question, why a not equal 0? Why do we require a not equal 1? Sorry, 1. 1 and 0 is the same thing. If a equals 0, well, a equals 1, what happened? If a equals 1, we can discuss. Yes, very good, thank you. That's very good, fantastic. Well, if a equals 1, you can tell that fx equals 0 to power x. 0 to x is going to be 0, 0 to 0 is 1, but it's basically it's a constant. Well, if you have x equals 1 to power x, what happened? It's always 1 to 1 is 1, 1 squared is 1, 1 cubed is 1, 1 fourth is 1. Because 1 times 1 times 1 times 1 times 1 is always 1. And it's going to be any question?
0 to the power 0.
0 to the power 0, I think it's 1. We can check it and say. You can say it's 1. Okay. 0 to 1 is 0. 0 to power, but 0 to negative, we can't do negative. 0 raise up to 0, see what's happened. I believe it's 1. Yeah, 0 to power 0 is 1. But 0 to negative, we can't have 0 to negative. Because if 0 to negative 2, you got 1 over 0 squared, and it's in the bottom. So 0 comes denominator. So 0 to 0 is 1. 0 to anything is 1. But 0 to 1 is 0. Anyway, that's a function which is not the total domain, it's constant. How about 1 to power x? It's going to be 1. Okay, 1 to 1 is 1, 1 to 2 is 1, 1 to 3 is 1. Question?
So why is that a problem though? Because it's not like it's going to give you
A
something
constant
impossible.
line, but, well, that's, yeah, you're right. If it's exponential function, what's the meaning of exponential function? It's exponential increase, exponential decrease. Or if it's a constant, it's going to be just a line. It's going to be, it has nothing to do with x, it's just a 1, basically.
Right.
You have a constant function, you have a horizontal line, which is just y equals 1. Does it make sense?
No, I understand it's going to be flat, but I don't see why that necessarily, unless you're sort of wanting a result in the end where it actually goes up or down.
Goes up and down for 1. I believe 1 to anything is 1, 1 to negative 1, 1 to 0 is 1, 1 to anything 1. It's going to be a flat level. So we don't define it as an exponential function. It's not a category of exponential function.
So there has to be a change.
It has to be
in
an exponential, because it's called exponential function. So you have to have exponentially increasing or exponentially decreasing.
Okay.
Make sense?
So it's a matter
Good
of
question.
definition, essentially.
Yeah, it's a matter of definition, yes.
But is it just a choice? Or is there something mathematically
Yeah, it's a mathematical definition.
wrong?
It's kind of,
with you?
not
Okay.
wrong, it's mathematical definition of, yeah, the definition of exponential function. Yeah, we want to do research on exponential function, not like y equals 1, that's nothing too much research on it, like it's increase, decrease, basically just a flat line. So we put a category is not an exponential function.
So it's pragmatic, the decision to exclude 1?
I think that's how it is. That's the better definition of that. Yeah. Okay. If you really want to know why we have to do that, we can discuss that later after the class. If
Right, I would disrupt this.
Yeah, but it's,
Later, Cosmo.
yeah, it's increase or decrease exponential. Otherwise, if it's, you see, everything else is increasing or decreasing. Now you have a flat line, a horizontal line, which is neither increase or decrease. So we don't say that's an exponential function. Yeah, because of the property or the definition of the function. All right. So now we want to determine which of the following is an exponential function. I want to ask this English professor.
Who would like to now be with his partner over there.
Well, okay, let me just look at it for a second.
Okay.
And
Which one is the exponential function?
it's either 1 or 2, and I'm thinking it's probably, I'm going to say 1 would be my guess.
We'll see. Look at
2.
Good.
Okay.
We can compare the form. This is the h power
Oh, I
s,
see.
and I say which one has exactly the same form.
Okay, yeah, 2.
2. Oh, how about 3?
No, because it's a negative number.
Oh, that's a negative number. You got it. So everybody got it? So it's 2. Okay, very good. Thank you. All right. So next, once we got a exponential function, we introduce the definition. You see a function, you say, oh, this is an exponential function. Next, you want to, if I have exponential function, I want to know how to. Sorry.
Oh.
I want to evaluate the exponential function values. Okay, so next one I want to evaluate the exponential function value. Previous in the previous classes we have introduced the function values, which is giving you a function. I want you to find out, give you x value. I want you to find out the y values, the exponential values. So now first I will give you example. Say fx example, which is fx equals 1/3 2x minus 1. I want you to find out f2, but this is the example I'm doing with you. So I want to find out f2, which is I'm going to plug 2 into the function, which is replace the x by what? By 2. So in the function, I will have 1/3, 2 times what? 2 times 2. Because here is 2 times x. This is x, this is going to be x here. So it's 2, so I'm going to replace this x by 2. So it's going to plug it in 2 and a minus 1. So then the rest of them is going to be just plug in, it's going to be 1/3, raise up to 2 times 2, which is 4, and 4 minus 1. And this is 1/3 to the power 4 minus 1, 3. Okay, now what is 1/3 power cube? 1/3 cube is 1. That's a good answer. But now, any other different opinions about 1/3 to the cube?
1 by 27.
1 by 27. Okay, how did you get 1 by 27?
That's 1 cube by 3 cube
1 cube
by 3 cube.
by 3 cube.
Oh,
Okay,
right.
got this is 1 cube by 3 cube. And what is 1 cube?
One.
It's 1. And 3 cube is 27. You got it, 27. So how do you get 3 cube is 27? What is 3 cube?
Times 3.
It's a 3 times 3 times 3. Okay, so 3 times 3 times 3, which is 27. Well, this cube actually means how many pieces you have. Like say you have 3 to the power 5. If it's 3 to the power 5, you're going to have 5 3's multiplied together. So it's going to be 3 times 3 times 3 times 3 times 3. You have 5 pieces. Does it make sense now?
Don't
Good.
ask me to do that.
Huh?
Don't ask me to multiply that. I can only go up to power
Yeah.
3.
You gotta go up 103. Okay. So well, if it's too bigger, don't worry. We have calculator. Okay. So I will show you how to use the calculator to find out some number which is bigger. Like say 3 to the power 5. Well, if you ask me, well, what is 11 to the power 5? I can't figure it out so quickly. I still have to use calculator. So here, I say it's 3 to the power 5, what do we do? We have, first is base, 3, and you see the x power y, you see this button. Okay, you can write it down, which button x power y, if I click it, you see that small arrow here, that's the small arrow here, so it's raised up to which power. So you click 3 to the power 5, and you got, which is, click equal, you got 243, okay? So if it's big numbers, you can use calculator. For small numbers, you can use your handwriting or brain math, it's okay. Okay? Alright, so now we figure out this. Next is a practice. I want everyone to practice. You have the classwork. Can you please work it together, figure it out.
Oh, you don't really want to.
If you have any questions, please feel free to ask me.
No, come back, come back.
Sam's got Jim.
You can sit together, like, it's okay, sit together, discuss with each other.
Okay.
So you've already jumped ahead.
Yeah.
Rewrite it as 1.
But I don't know if that's we used to get to that. Yeah.
Right. Well,
Yeah.
1,
Yeah.
the power of
Yeah.
0 before the second one. So this is
Yeah.
technically what I
Essentially what you're doing, when you replace it,
right.
Does anyone have a pen? Okay, thank you.
Okay, that's easy.
Oh, good.
I knew.
Okay, so that works.
So, it's 1/4.
I'll check the answer with you.
This is like 2. It's 2 times 2.
9 to the right.
So that
And then
thing
4 to the
about
4th power.
So
I didn't know that.
we just shift the whole graph.
So that would shift the whole graph, which means that
Yeah,
it's
it's
1/4.
That's plus 3.
It's still 64.
Yeah, you can do either
Is that the same thing?
Right.
Well, okay, I was gonna say,
I was a teacher and he didn't let, he didn't put it.
so to do it again, you would just be like 4 times 4 times 4 times the other 4.
This is 1/4.
So that should be to the right while you're down.
that's probably the bigger.
So, the second to last is the same as the.
Yes.
But, okay, and again, if it was.
Yes,
it
it's
gives you 6 power. With this, it won't either.
Yeah, you probably don't get
Now I better get honest to go on.
Yeah, and if you have trouble with, let's say, 4 times 1.
Okay, so go ahead, you take the lead on this one.
Evaluate the exponential function.
Anyone, does anyone have any question? I can walk here and check your answer if you're right.
Yeah, I don't, I guess that's right.
Oh, that's good. You got it right.
Why is minus 9
That's very good.
Wait,
Okay.
You guided us.
You got it
Really
too.
good.
That's very nice. You got it
If you
too.
put in
Oh, very good.
0
Okay. Just
there.
check everyone's
Minus
answer.
9 would take us to the negative, to the
So-
left.
Yeah.
We're not.
Don't minuses always take us to the left?
Generally,
Why is it x plus?
Oh, you go in advance, so we just do the first one and the second one. No, we just do the first one. Practice. Oh, it's not that. No.
So this
Oh,
right here.
just pay attention. You only have to do the number 1 and number 2, which is right here. Find out this. I'm gonna put it right here. So only do number 1, number 2. You do not have to number 3, number 4, but you can fail to do. But it's just number 1, number 2. Okay. Everyone, did you finish number 1 and number 2?
No.
Okay.
We didn't realize we were two.
Okay. Okay.
We weren't paying attention.
When you evaluate a function, so this is actually 4 to the power 2 times
Oh, wait.
replace this x.
But I suppose you only
That
keep
2
this
so 2 to 2 times.
yeah, so whenever you start, I'm not remembering how that math very well, I just remember that whenever you're translating along.
Yeah.
So 4 minus 1 is 3, so 4 is just this.
Because it was, right, because 9 minus 9 is
Yeah, yes, that's
Four
the big one.
minus one minus three.
Right. I understand this, but now in terms of,
I wrote it down, I was trying to show you the steps, but
oh,
I
oh,
don't
oh,
know.
okay.
It's like 4 2 times 2 is 4.
Yeah.
So we have minus
4.
minus
Yeah,
six.
minus
Normally
one.
So
where
now
you
4 minus is 1.
Three. Yes. We use a calculator. We can do 4 times 4 times 4. Yeah, very good. Very good. Yeah. Okay, everyone, did you finish it? Yes? You got it, right? So now I'm going to check the answer with you and see if you got the right answer, okay? So first, I will check the answer with you. The second one, you plug it in. Since you haven't finished it, I will just write down the answer and do it with you. So F3, you plug 3 into the power. You got a 1/4 to the third power. Yes? And then you got 1 to the... Can anyone tell me how to do this? Anyone?
4 times 4 times 4
Is 1 over...
64.
how did you get 64? Okay. How did you get 64?
We 4 cubed.
Oh, you got 4 cubed. Yes. It's going to be 1 over 4 cubed. And 4 cubed, you multiply 4 times 4 times 4, you got 64. Okay, very good. Yes, very good. Thank you for your answer. Thank you. Next one is going to be F2, and you plug it in, so it's going to be 4 to 2 times what? Anyone tell me? You plug it in 2 times 2, then minus 1 equals 4 to the 3, and then this equals 64. Okay, very good. Thank you. So next one, if I give you a exponential equation, you will be able to evaluate the value. The next one, we will talk about the graph of the exponential function. So if we talk about the exponential function, we want to graph it. How does the graph of exponential function look? We want to know the graph of the exponential function. You have an idea, okay, this is the exponential function. Let's graph the exponential function. The first one was to look at the function fx equals 2 to the power x. Okay. So fx equals 2 to the power x. We're going to graph it. If we graph a function, we sketch a graph. We have x values, and we also need what? We need x and what? And a y. We need an x and a y to graph a function. So I have given the x values. Next, I plug x into each of them. So I write it on here. So x, and the other one is going to be fx. If x equals -2, so I plug -2 into here. So it's going to be 2 to -2. Okay, my question is, what is 2 to -2? 1 over 2 squared. Very good. Okay, it's 1 over 2 squared, which is what?
1/4.
1 over 2 squared, which is 1/4. Very good. Thank you. And next one, we continue with -1 and 2 to what? -1. Okay, 2 to -1, which is 1/2. Okay. So next one is 0. How about 2 to the power 0, which is 1. Okay. And next one is 2 to the power 1. I think this 2 to the power 1 is going to be 2. And 2 next one is 2 is going to be 2 to what? 2 square, which is 4. Next one is a 3. Plug it in is 2 to the power 3, which is 8. Okay. Now I have all the x values, and I also have all the y values. Then we can sketch the graph. Let's just put it in a pair of coordinates. So x is -2, and y is 1/4. So next one we do the same thing. X is going to be -1, and y is 1/2. The next one is x is 0, y is 1. Good. X is what is x? 1. Y is 2. Yes. X is 2, y is 4. Okay. X is 3, y is 8. Okay, very good. Okay, once I find all the values, then I plot all the points on a coordinate plane, coordinate system, like x and y. Have a picture. This is x and y. Okay. So we're going to plot all the points in this coordinate system is 0, 0. So the negative 2, 1/4. I'm going to put it right here. 1, 2, 3, and 1, 2, 3, 4. May have more, but 1, 2, 3, 4, 5, 6, 7. Sorry, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, maybe not down here. So now we have all the this one. I mean, I'm going to do it very quick because this you have your if you have graph sheet paper, you don't have to do this by yourself. Because I do it here. Now we're going to sketch the graph. We'll plot this one. So -2. First we'll find out -2, which is x values. So 1/4. Where did I put 1/4? We're up, but it's less than 1. It's roughly going to be -2, then up a little bit right here. Make sense, everyone? It's just 1/4. I mean 1/4 of this. It's below 1, but above 0. But under first -2, then 1/4. The next one, I just put a little bit down a little bit. Next one is -1 and 1/2. So we start from -1 and 1/2 right here. Okay. So this is 0, 1. X value is 0. Y value is 1. So it goes to here. And then if I go 1, 2. So start x is 1, y is 2. So x go 1, y is 2 is right here. And then start. Next one is 2 and 4. So 2 and go 4. So 4 is right here and 2 is here. The intersection point is going to be here. Okay, next one is a 3. I'm going to do 3 and 8. It's going to be right here. Then if I connect those points, and then this is going to be sketched. We sketch the function of. Oh, sorry, don't touch it, but okay, this is going to be the function of y equals 2 to the power x. Does anyone have any question? Any question? Question?
Can you, I'm just trying to think, can you use exponential functions to do and then plot it in 3 dimensions?
Exponential function to plot in
3 dimensions, like a sphere?
sphere, 3-dimensional.
Yeah.
Well, normally if you say 3-dimensional pictures, you are going to have 3 variables. Here if you have y and x,
Okay.
you only have 2-dimensional variables.
Right, so
if you have if you have z coming out, you can plot like a 3-dimensional. But so far our college algebra, we are going to focus more on the 2-dimensional, just y and x. We don't involve z. But if you are interested with this 3-dimensional function, we can definitely discuss that after class. Okay.
No, thank you.
All right. So next, so we have the function like this. Okay. How about since in the previous class we talked, we talked about the sketch, the graph, shift of functions. Now, if I add 3 onto 2x, how I'm going to shift this graph? How about if I have a function, function f(x) equals 2x plus 3, 2 to the power x plus 3, what I'm going to do with this graph here? Can anyone tell me the answer? Okay. So I'll tell you how to do this one, but you're going to tell me your.
There were a couple hands.
Sorry.
Yes.
It's my bad.
Oh, go ahead and answer it. Tell them how well you're doing.
Tell me what I'm doing. That's a good. That's great. Let me see. Like I want it.
Yes, mother.
Okay, it's supposed to be like I silent there. Everyone. Sorry. Then,
Start.
well, in my class, if this happened, everyone will get 1 point.
Yes.
Yeah. If this happened, all the class will have 1 point. However, if someone is texting message, they got 1 point off.
The whole class
For the
gets
whole
it for
class?
one person type?
Yeah.
Yeah, good.
Like if I did some mistakes, my fault, the whole class got a benefit from me. If they did something like a valid plus rule, I got 1 point. Well, in the end, we are going to balance the point.
Yeah.
So that's how it works. In this case, if I write something wrong here, if I say, oh, I write 1/3, well, they catch me, they got 1 point. Okay, so it's kind of way to play like a.
And you really show evidence of that? Like, do you keep the whole class scores somewhere where they can see you really gave them the points?
Well, it's a sheet. Like I have this, I bring it with me. You can just add 1 point, and then in the end, well, it's actually not that important. 1 point out of 1,000.
I know.
It's a it's a game.
Mentally,
Yeah,
it's important.
like then they talk to you, they're gonna say, shh, don't talk. You're gonna have 1 point off. They don't know. So it's how it works. Like
Minus 1,000.
you know, the denominator is 1,000. Okay, so now if we're plus 3, which means we add 3 on all the values here. So all those y values, you add 3. You see 2 to the power x plus 3, yes? So everything will add 3 here. So this one, because you have added 3 here.
So 3 1/4.
Yeah, if you add 3 here in the on y value, see the right down here, right here. So if I have 2x plus 3 here, sorry, 2x plus 3 add here. So all the y values will add 3. So see the first one, I plug it in. If the first one I still do the same thing, I'm going to have x and y values again. If I plug it in, I will have, say the first one is -2, you plug it in. So it's going to be, first it's still the same, 1/4. Make sense? You plug it in, it's 1/4. But you add 3 on 1/4. Why it happened again?
2 points.
Oh, we're
2
getting
points.
rich with points.
He is doing this.
Sometimes it's like a, let me just 1 second, let me just turn it off. Oh, it should not happen. Like I turned off. So sorry.
Just a trash can.
And that's what I think. I actually silent it, and I don't want to call me this time. I don't. I hope it's. Okay. Whatever, it's not going to happen. I hope not. Otherwise, you got too many points. Okay. So now I have -2, 1/4 plus 3. So all the points will add onto the y values. So you have this one is 1/4 plus 3. Next one you have the same thing. So it's -1. You have -1 plus 3. Make sense? Yes? This one you have 0. You have 0. You have 1 plus 3. Basically, you have plus 3 on all the y values. Does it make sense? Yes. You add 3 on all the y values. So let's say if you add 3 on all the y values, you're going to shift the whole picture 3 units up. Make sense? Because every single point will be added by 3. So, question?
Does that mean, essentially, does that mean that it just exponentially raises more quickly? That it's happening?
No, it's if there's 3, it's just the add on y values is not x. It's not. It won't affect the increasing rate. It only affects the average level.
Okay.
Yeah, it's not dramatic. It's not. The shape is the same. It still have the same shape, but the whole graph will move up 3 units.
So like if this were grains of rice, it wouldn't change the rate. It would just change.
Yeah, that's a
the
good
starting
question.
point.
Let's go back to the rice. So if the rice here, if this rice, well, you only have a 3 here on the end of the values. So here you have is going to be a 4 and a 5. So all you have to add is each value. Like look at it here. You only add a 3 on the last digit. So it don't really change the increasing tendency.
Right.
Yeah, you just move the whole function up 3 units.
Oh, I see.
Make sense?
Yeah.
Okay, the shape won't change. We just shift this, just kind of like shift it and shift it up 3 units and move it up 3 units. They still have the same increasing rate, same shape. Make sense? Okay. So this is the graph. Oh, okay, we're gonna have it right here because everything is go to 4 units to here. So you're gonna have this. Okay. So you're gonna have exactly the same shape, and this is y equals 2 to power x plus 3. Okay. How about minus 2 on the exponent? Previously we talked about the shift graphs. If you add values on the y, you shift up or down. Okay. If you add values onto x, you shift it to left or right. Yes. Based on previous class, we have already talked about the scratch of the graph. Now we can talk here into this. We can talk here, so you can see x minus 2, right? Which means you minus 2, say negative 2. You minus 2 here. You plug it in all the values. So here x minus 2. Well, is it shift to right or shift to left? To left, everyone? To right or to left?
Right?
Is it shift to left or right? To the right. Okay, I have right. Shift to left or right?
Right.
Right. Very good. You shift to right or left? Just guess.
Right.
Right. Okay. So now I'm going to tell you how to shift your right or left. Okay. So there's a quick way to memorize it. You just make this one, whatever this is, set up equals 0. So x minus 2 equals 0. X equals what? 2. Is 2 positive or negative? Positive to right. So if this number is positive 2, it's the right 2. You shift to right. Okay. So now we have, if you say you have x plus 4, you don't know if it's left or right. You just set up x plus 4 equals 0, say the exponent. So your x equals negative 4. You solve that, it's negative 4 to left. Make sense? You set up the this exponent equals 0. If x equals positive, you see the x-axis to the right. Yes, that's how you determine shift to right or left. The same thing with the plus 3 or minus 3. If you plus the values on the y values, if you add 3, you see it's going to be up. Yes, add positive 3 is up. So here it's positive 3. It's add on the y values, not independent with x. You add on y values, so you up because positive 3 on the y-axis is up. If it's minus 1, you go down because it's negative. Does it make sense? Okay. So now I want you to the next question is number 3.
Just go ahead.
That's okay. Feel free to change your groups. Feel free to, if you can walk into classroom, it's discussing time. Just relax.
Can we be in any group we want?
Sure, any group you want in the group, and it's a discussion group. Yeah, sure.
So let's say that there's this really good group that's formed in the class, and I'm not in a good group. Can I just?
Sure, you can. Yeah, you can just. It's a study environment. You want to study with each other, learn from each other. It's always welcome to switch the groups. It's good. Yeah. Feel free to do as long as it's study, discussion, study. That's okay. You can switch to any other groups.
We usually need to balance it.
And then,
Not with the X, but down.
Does it usually work out, or do you have some others?
up and down,
There are some.
up and down.
And some people want to do
Some
that.
people really like to be, they like to do things on the ground.
Oh, I
Some
see.
people have
Very good.
Did you explain how you got it?
And actually, Ryan just explained to me.
Okay. So if you explain to you, you got it. That's very good. Yes. You got it.
Yes, he explained it to me.
Oh, he explained to you. Very good. Thank you.
It's kind of going down.
I got it done down. Okay, very good. I hope the message is exactly the same. Okay, so the shift to 2 units to the right.
You know, at one time I was really good at this. Really good at this.
A little bit better, but it's fine.
The math times the
A long time ago, 1986. 82.
I discussed the problem. Yeah, if you have time, you can try to do next one. Yeah, and try to discuss something which you do not understand from the previous part, like questions, understanding each other. All right, you got it. Is it translated 9 units to the what? To the right, yes? So 9 units to the right and 3 units up.
You're not exploring what happens with them. What that first change this is 0. And then rate
Okay. So did you finish it?
Yeah.
Did you finish it? Okay, anyone tell me the answer? Anyone tell me the answer, please?
Because this makes total sense to me.
Okay, you got it. Answer is. You got the answer is y equals
E to the x minus 9
e to the x minus 9
plus 3.
plus 3. Okay, does everyone agree with this answer? So now?
I agree.
You agree? Anyone? You agree with this answer? It's shift to the right by 9 units and up 3 units, right? So, okay. Can anyone explain how you got it? Anyone explain how you got it?
If we are talking about shifting right, then we are talking about the x, and so, then based on how you explained it, it becomes x minus 9, and then shifting up would mean adding to the y value, and so it would add to the.
Okay. So does everyone got it? Anyone else? Do you still feel you got it or not got it?
We'd like to
You
meet
got
with
it?
you after class.
please.
Increase your office hours.
Yeah.
Yes, feel free to come to me and yeah, feel free to come to me for questions. And I'll be in my office from Monday to Friday. All right, so here I'll explain again in case you still feel a little bit confused. Okay. So now I said is the question is shifted to the right by 9 units. Yes. So based on what we've explained, if it's a shift to the left or right, then the number is going to be on what? Working on x values. Because left or right is going to be x direction. Up and down is going to be y direction. Yes? Look at it. Look at this. Left or right is x. Up and down is y. So that line, shift to right 9, that 9 is going to be working on x. So basically, right to 9 units, you must have a solution. So you say x, maybe you're not for sure, but you say, oh, it's going to be 9. It's going to be either x plus 9 or e to x minus 9. But you know it's going to be 9. Yes? So you figure out, well, is this one or this one? You have to figure out sometimes, but if you work more, you don't have to do this way. Well, if you do this, you just think about, okay, this one, x equals, if x plus 9 equals 0, x equals negative 9. Or if x equals negative 9, it's going to be to left, yes? So you got this one, x minus 9 equals 0, x equals 9, yes? or you figure out this, oh, this is positive to the right. This must be the answer I'm looking for. Okay? So at the beginning, you may have to try like twice to practice. Well, later on, if you do more practice, you can figure out very quickly. Okay? So that's why we need to practice for the math. Like practice makes perfect. All right, so y value is much simpler because you just add, your y values is you add the values onto y, which is independent with the x. So basically you add, if it's up, it's add 3. And if it's down, you minus 3. Okay? Everyone got it?
Yes.
Yes? Okay. All right. Okay. So,
So we're getting kind of close, so it might be a wrap up sort of.
yes. Oh, I think today we have not talked more about the application. Is in next class we'll continue talking about the exponential function application, and today we have introduced the exponential function. Why do we learn it? And definition of exponential function, evaluated exponential function values, and a graph of exponential function. Well, we will continue next class with the application, which is very interesting, very important, because after you learn that, we're going to know how to use it in the real life. So today, I hope you go back and you do your homework, which is Alex will use, and you do that section homework. You can feel free to come to me for help, and during my office hours, or email me. We also have private free tutors in the Student Success Center. Go into Student Success Center, they have tutors help you with the exponential function if you have questions. Okay? Thank you for coming to the class. Okay, see you next time.
All right, so I'll just keep you on here for a bit. We'll sort of talk a little bit within the group, and
Okay.
then we'll send you to lunch.
I'll take care of that.
Okay, I do it.
I'll take care of it.
Yeah, maybe next class, the next professor will come. I want to teach you paperwork to that.
Take care, go ahead.
Oh, you might just want to take the mic off.
Okay, that is, take the microphone. I'll take the microphone off, sorry.
All right.
I think now I can check who is calling me.
Yes.
But that's
Gary will tell us.
He's had a class in methods.
He's had a class in method.
All right, definite no, right, folks? Definite no?
Absolutely. I mean, I veto all the time.
I mean, can we just save the money on lunch and dinner?
No, I'm
I will say
really
yes.
excited about lunch. So dinner is fine.
Dean,
Well, I would just say,
in a contract?
You will all learn that he is in his first year at Broward in Miami, and he's been nominated for Teacher of the Year already. So, I mean, it's clear that this gentleman knows how to teach.
Yeah.
Oh my God. Yeah. That's really
He's had methods classes.
Do we have enough money?
totally thrilling.
That's the,
He was
our
very-
salary is
So
more
it's
than
gonna
12,000
rise.
below his current salary.
Right.
Oh,
why
okay.
didn't you
So
say why he applied?
less, we already discussed that.
is he toying?
Can we contribute?
No.
There are good reasons why.
Okay.
Oh, I think.
But, so we're all happy with the teaching? Is there, what was your take? So you've seen a couple of,
Yeah, this is the second one I've sat in on. He seemed very confident, he presented very well, and I really couldn't find very much to criticize on. If there was one thing that I could point out is, I think that he could have expanded a little bit more on when you asked the difference between his, the 0 to the power of x or 1 to the power of x. And he just brushed that off as the definition of it, and that's why those aren't exponential functions, I feel like he could expand a little bit more on that and compared why that wouldn't be the case, why those aren't exponential functions, being that the biggest difference between those and the real exponential functions, those are ended up being defined as linear functions, because they would end up being just having a constant slope. Exponential function is exponential because its slope is constantly increasing in one direction or decreasing in another. If you're looking at a more of a decaying function in comparison to a polynomial, which has, for example, increasing function for decreasing function for the other half. It's just constantly increasing.
Right, okay,
So
that
that's
would
one
make
thing that
sense,
he
yeah.
could have done better on. Otherwise, I think I did very well, almost perfect, other than just that one point. I didn't
Well,
think couldn't find anything else I could
There's one
criticize.
other thing that he did, and it's very, very tiny, but,
The graph?
the graph.
Yeah, there was an asymptote at
The
y
asymptote
equals
should have been at 3, he dropped below 3, and he didn't really discuss it at all, but it should not have gone, it should have, when he did the shift up to 3, everything should have stayed above the 3 line, and he didn't really discuss, what happened, that the x-axis was the asymptote on the first one, which maybe he should have discussed. And then he would have brought in that when you moved it up 3, that asymptote shifts up 3 also.
Yeah,
Yeah,
because that did confuse me, right?
And it might have, especially when he dropped it down like that, it looked like it was going back down to the x-axis the way he had it drawn, which could cause confusion with students looking at that.
But wasn't that about the same time that his phone went off, maybe? I think maybe he was a little thrown by that. I
Oh,
don't know.
see, and I thought that was great that that happened. I mean, I would have been horrified. I thought he just handled it so well, and we got to see how he handled himself in that event, and yeah.
Yeah, being nimble when things go wrong, which they do all the time.
I like the interaction that, well, I wasn't here yesterday, but the first two people didn't really have. It was more like a talk about.
Very encouraging, warm,
I mean,
supportive.
of the 7 candidates that we have seen so far, I would say he's been by far the most interactive.
Oh my goodness,
And
yes.
it's not terribly close.
Oh, there's nothing close to
Do we have a
this.
shot?
This
This guy's
was,
like Richard Simmons compared to Jerry Falwell.
we just
I
promised
have
to
to
give
ask
him
you,
lots of
it's an
news
immigration
recognition awards.
All right,
He was
so
very outgoing.
Okay, we're going to
I've
lunch.
got
Okay,
nothing.
we're going to lunch. Do you want your thing with all your answers?
Yeah,
Right, Matt?
Put it up on the fridge.
I never got any right answers from Matt, ever. Just got partial credit, so I was
I don't know, this guy might give you a run for your money.
The system works with immigration. So
Well, I don't know, Alex could probably just teach it, right?
We should.
Yes, based on immigration.
And I will make sure.
Because yes, but it is something that he's been asking lots of questions that I couldn't answer. He said,
Right?
if I get the salary, that even if I try to
Somebody-
somebody for
Talk to you about
something,
that,
Somebody
they have to
I have to go out and
Somebody
buy my family and
brought up,
stuff. Can I
you
get a
know,
house
don't
or can I
have
buy everybody able to afford? He's really concerned about, you know,
well, next year
because
we will.
literally with his
Maybe.
salary.
I don't know if you have to accept.
I probably, I gotta be there.
Yes,
So that's what we have to talk about.
Alright.
Thank you, sir.
Thank you.
You rent the
That makes sense.
So I'm
I understand one.
All the houses on the road were
Okay,
$700.
a home for
Well, then they would know.
We'll probably soon go for it. There's only
He
one
also
going
has
on.
questions about the quality of the school system, he didn't reach
Which we
his
know is
child,
very good.
which you would have to talk about. And he's worried about the increase in salary over time, which I said, we're trying to fix that, but right now it's a problem.
Oh, I don't need my keys.
We know he would have 3,000 a year in professional development. If he has promised to do 1,500 for the department. So the first year we could do 1,500 and we apply for that each year.
He really is.
So, okay, we will.
If his questions
Do
are
the
how
best
we
we
know,
can. All right, we've got a job.
but the immigration isn't an issue, I don't believe.
Well, that's
all the
a
chocolate
pretty
ones
big
are
thing in our
delicious.
favor, though.
Yeah.
Oh, yeah, you're
I
welcome.
said 3 dinners.
Do you guys sit in the back in the close-off room or out in the?
Oh, they just wherever they sit us. So far, it's been all in the front area. But I mean, it's nothing special. Although you guys will have to, like, we've been putting